So some of this programming business can be a little bit confusing. So I figured I would just make a video just explaining this. So for now on, for the most part, we're just going to be working with ActionScript, which is a programming language. So slash scripting language. Basically, it's you can see right here. It's an object-oriented scripting language, and basically what that means, it allows you to make objects. Think of them as objects in the real world that can do things, and then you can basically organize a bunch of these different objects and then use all these different objects in order to make things happen, right? So look at it the same thing as, like, if I wanted to build a car, I could have a wheel object and an engine object and like a frame object, and I could have a bunch of different ones, and then they all do different things, and I could put them together in order to make a vehicle I could drive. Okay, so that's kind of the idea behind it. Okay, so when you are thinking about programming, the best way to think about it is to think of it like any other language, right? We call it a programming language. Like, this language is ActionScript. There's JavaScript's the language. C# is, there's a bunch of programming languages. But think of them in the same manner as that, where basically the two things you have to deal with are going to be syntax and semantics. So the syntax is the grammar. So basically it's the way it has to be written, right? So when we write English, it needs to be written a certain way, right? We start with a capital letter for a sentence, right? Usually there's a verb and a noun, or a noun and a verb. There's a space between each word, and then there's punctuation on the end of a sentence, right? And then you put another space, and then you can do another sentence, and you can put a sentence after another sentence after another sentence. They're all supposed to be, sentences that are alike, that are sharing the same subject matter, go into a paragraph, and then you can do another paragraph, and then another paragraph, and if you have enough of them, you create an essay, and then if you have enough of, man, JD, you were being loud. If you have enough of those, and, you can make a chapter, and then it becomes a book, right? Same basic concept. It has to be written a certain way, and then basically they all build on themselves until you create a really big behemoth that no one can understand, okay? So the ActionScript structure generally, or programming structure really, the things that you're going to see, the elements, components of it, are going to be variables, statements, functions, objects, and classes. Okay, we're not going to really be dealing with classes too much, but a variable is basically, we're going to go into these later on, but it's just a container that's going to hold a value. It's the same thing that you would have done when you were in math class, where you do x plus 12 equals 24, and you like solve for x. That x is a placeholder. That's all a variable is. It's just a placeholder that holds something, okay? Statement, it's just a line of code. So the thing I just said, this plus this equals this, that's a statement. That's one line of code. A lot of the line of codes, generally, they usually fall into one of two categories. It's either going to be some sort of mathematical or a comparative statement, okay? Function is a block of statements. So you put enough of these together, and then you can solve, it can run something, right? So functions, literally, it's just a bunch of lines of code that are in a block, and you can tell that function when to run whenever you want it, okay? So you can have a whole big, like, basically a list of directions, which are your statements, right? Like, and then basically you can say, whenever you want to run that list, you call that list up, and that list is the function. An object is the same thing that an object is the same thing that is in real space, where basically it'll have variables, which they call properties, and then it will have functions inside of it, things that it can do, all right? So, metaphorically, well, you get the idea. Okay, so variables, the way they must be written. Variables may store, update, or replace data, right? So, the way it needs to be written, the syntax of it is you write var, so you can see it here, right? You write var, that's a keyword. You can't use var for anything else. Var means variable. And then you have the name of the variable here. That's your own unique name. It can't be a name that's already being used by ActionScript itself, such as var, right? Or in this case, int, or number, or whatever. There's a bunch of different predetermined words that you're not allowed to use. They're keywords, okay? So as long as it's not one of those, and it also needs to follow some other rules we'll talk about in a second, okay? But basically, you can create whatever you want to call it. Obviously, you should name it whatever makes sense for what it is that it is holding. Then you have the type, which is right here. You do a colon and then the type. And so in this case, it's an int. An int would be a whole number, but there can be other ones like numbers, which can hold point values, or string, or Boolean. Boolean holds true or false. So in this case, it's an int. And then the last thing is the actual value that it's holding. Okay. Now, you don't have to necessarily put in the value when you declare a variable. Declaring a variable just means when you make the variable. When you write down the variable, you don't have to include what it is, okay? And then every statement, when you're declaring a variable, that would be a statement. It's one line of code. It needs to end with a semicolon, okay? So that's how it works. So basically, you have to write var, whatever name you want to give it. So this is a custom name. And then you say the data type that it's going to hold. And then if you want, you can give it a value as well, right? Now, obviously, the value has to be of the type that it holds. If I put a name in here, it will throw an error and be like, that's no go, okay? Some rules for the names, okay? The name cannot begin with a number, right? It has to begin with a letter. It cannot include spaces. So notice I wanted to write my score. So what I did is I used what was called camel case. And the idea is that you start with a lowercase for the first word, then you uppercase, then you do, for the next word, and uppercase the first letter of each word. And you can see here, you can actually read a whole sentence without spaces, right? Not a big deal. You don't even need spaces. We've been lied to our whole lives. But if you don't put spaces there, much harder if camel case is not used, even worse in all caps, okay? This is much more difficult to read. You cannot put spaces in your variable names because it's going to assume that those are two separate things, right? So there's no spaces allowed. You can't use anything but letters, numbers, or an underscore if you so desire. And obviously you can't use a reserved word, like I said. So when you want to give it a variable assignment, when you apply the actual value here, you can see there. These are different types of data that can hold. So int if you want to do whole numbers. Number if you want to do floating point numbers, so it'd be float in other programs, or double sometimes. String if you want to hold text. Boolean if it's a true or false. An array, which is a list of items, and then there's other stuff as well. All right, so that's what holds. Don't worry about scope, because that's actually not going to be an issue, because we're only ever going to write our stuff in we're not doing anything like that, so we can ignore that for now. So what we just did, this is a statement, and this is a statement, and then this is a statement. You can tell when it's a statement because it actually has a semicolon on the end of it. Basically, a statement is just, like I said, it's like a sentence. It's a sentence that does something, all right? So it could be a variable assignment, a mathematical equation, and then this is a function call. Yeah, so that's what a statement is. So every line of code that has a semicolon on the end of it is a statement. You'll see there's some lines of code that are not statements per se. Comments. So comment, you can comment out stuff. Basically, it's a way of leaving notes. So see, I did // that will work on a single line of code. If I were to hit enter and then write blah, 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 these / would not work on there. It only will work all the way across. So it works for one line of code. Basically, what will happen is that when the computer reads the code, it will ignore these items here. That's what the comments do. You might be like, well, why would I put those in there? They don't seem to hold any purpose. It's to leave notes. So it's leave notes for yourself so that you're like, oh, this section, like I do it all the time, right? So like this section handles jumping, and this section handles running, and this section handles, such and such, right? If you want to do multiple lines, you do a / semicolon. Then you write, you could write sentence or line after line and line, and then when you're done, you just close it with semicolon, not semicolon, asterisk, / okay? I think I might say semicolon here too, but it's asterisk, okay? Operators. So operators basically are just the things that you use in order to, do math stuff, right? So plus is obviously addition, there's subtraction, there's multiplication, there's division, and there's modulo. If you do modulo, it'll give you the remainder. I don't think they teach that in school anymore. It's finding the remainders, but if you did another thing and then you divide it, how many are left after the division. This actually can, believe it or not, this is actually useful quite a bit when you're trying to find like if you're trying to randomize things or trying to find whole numbers, it can be useful for that. We might use that actually a little bit. So these are obviously your basic math operators. Now another thing you do is these postfix, and basically it just means that you put a plus plus after the variable, and it will literally just add 1, or you put a minus minus after a variable, and it will subtract 1. Obviously, as long as it's a number or an int. So if I did, my score plus plus, and let's say I did my, var my score int 90, right, equals 90. And then the next line of code I did my score plus plus, that would make my score then 91. And if I did my score minus minus, it would make it with a semicolon. It would make it 89. All right. So that's what this is, increment and decrement, super useful. Logical operators, basically if I do 2 ands symbol, that means, or 2 ampersands, is that what they're called? Basically it just means that this and this, both these things have to be true. If I do 2 straight braces, I don't know what those are called, but the vertical braces, that means this or this has to be true. If you put an asterisk in front of something, it means not that. Yeah, and here's some other stuff too. You'll see when we do this, but basically these are kind of if you want to come back to this, you can look at it, but this is going to get it's more confusing and not necessarily helpful. So some things that we use are conditions and loops when we're writing our code. And so basically you can do an if statement. So if, and sometimes it's called if else, if then else. So we'll say if what's in these parentheses is true, it's going to do what's inside of these brackets, else it's going to do what's inside of here. So for instance, if I did if the score is greater than or equal to 75, so what's inside these parentheses, if that is a true statement, it's going to run what's inside of these braces, and it's going to say trace pass, which means it's going to write to the debugger pass. Else, it's going to run what's in these braces, and it's going to write loser. Okay? So that is an if else. We use those a whole lot. So we'll just say if this is the case, do this. If this is the case, do this. If this is the case, do this. Else, do this. And so basically you can just run a bunch of that. Okay. So for loops, basically it'll run a loop for as long as a statement is true. So for as long as what's in these parentheses is true, it's going to run with these braces. As soon as what's in these parentheses is no longer true, it will no longer run what's inside of this block. So for instance, if we make a variable score, it's an int, we start at 0 and we say, oh wait, this is a while loop. Whoops. Right here, I gotta swap those out. So we say for variable I int 0. So we'll say I is 0, and then we'll say while I is less than 10, okay, and then add I every time it loops. You'll see this will make more sense when we do it. It will write I, and so basically this is going to run from 0, 1, 2, 3, 4. It's going to write out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not going to run 10 because it's while I is less than 10. Now a while loop says run this while this is true. So that'd be like this. So we start out with 0, and we'll say while the score is not 100. So while you haven't scored 100, you're going to do the score plus 1. So basically it'll write 0 up to 99. And then there's a do while loop. So the do while loop, what happens here is that it will run until until the afterwards is not true. So it always runs once. That's basic. We're not going to use this anyway, but that's what that is. All right. So we will be using those a little bit later on, but more or less what these are for is that we just say, if this happens, then do this thing. It's just super useful for just testing things. So like if they're pressing left, make them move left. If they're pressing right, make them move right. That kind of a thing. Functions are basically they're a way of running a bunch of statements. Basically all function is a list of directions, and you can call that function whenever you want, right? So I'll be like, I have, look at it like recipes, right? So I'll have like, oh, a recipe for making spaghetti and a recipe for making chicken pot pie and mashed potatoes. And then every time I want to make chicken pot pie, I can just go, hey, chicken pot pie, and then it will run through and make me chicken pot pie based on the instructions that are inside of there. Okay. So typically what that means, is something like this. You could have you have to have the function. So you write function for the name. So just like we write var for a variable, you write function. That's the keyword that says this is going to be a function. Then you have a unique name for the function. And then these parentheses. The parentheses are the parameters. And basically, let's do the chicken pot pie thing again. Let's say I want to make beef pot pie or chicken pot pie. What I could do is that in the recipe, I could send it beef or chicken, and that would go in these parentheses. And then when it runs the pot pie, it would make the meat out of whatever I sent it. Okay? So that's what, most of the time, these parentheses are just going to be empty. I don't even know if we're going to send it anything. Okay? But if there is something to be sent to the function when it runs, then they would go into here. Okay? All right, so then we have these, and then it's just going to write this. Okay, so then inside of these braces is everything that belongs to this function. So when this function gets run, whatever's inside of this brace here, these two braces, and usually there's a whole bunch of lines of code. I just did one for the example here. It's going to run what's in those, and that'll be it. Now, this function is not going to run like this. I created the function, it's there, but it doesn't actually run. You have to call the function. You have to tell the function to run, right? I can have a whole list of recipes. They're not going to work unless I put them to work, right? So in order to make this function run, I'd have to do a function call, which would look like this. So this name of the function is hello world. So you write hello world, and you put the parentheses there, and then the semicolon. And then it will run this function. So this will run because at the end, I actually tell it to. So probably a little bit of a better example. This one actually does look for, I do have to send it values. So let's say I want to have a function that's going to find an area, right? So function find area. Obviously, if I want to find area, I need width and height, right? So when I call that function, I'm like, this is the width and this is the height. So inside of those parentheses, I would say width, int, and height int. So it's expecting 2 ints. And then when I call this function, and you can see right here, this is how it actually does it. So it says, I made a new variable called area, and it is going to be equal to the width and height that it gets sent, and then it will return area. So right here, I just did the shape area int is going to be equal to find area, which is this function. So this is the function call, and I'm going to send that function a 5 for its width and a 7 for its height. Okay, and then I just write out what this variable, I keep saying variable because I say var, but this variable would be. All right, so objects are actually the same things as we have already covered. So all objects are basically a big thing of code, a big box of code that holds functions and it holds variables. They call it something different when it's in an object, but that's what they are. So a function will be called a method if it's inside of an object, and a variable would be called a property. So the way to look at like an object is like a car, right? So I can have a car. It can have variables about it, right? The car can have properties or variables. Same thing when it's, so it could be, they're just called it's variables, but they're called properties when they're inside of an object. Okay, so basically that car, it could have a color variable. So it could be red, or it could be yellow, or it could be blue, right? So and it could have other things about it, like it could have a V4 engine or a V8 engine, right? And it can have a different make and a different model. It has all these different properties about it. And then it can also have functions. So a car can do things, right? So I can tell the car to go. I can push on the gas and the car moves forward. I can turn on the lights and the lights turn on. And I can turn on windshield wipers and the windshield wipers work. And you can tell it to turn on a radio and the radio works. And you can roll the windows up and down. Those are different functions that it can do. And those all exist inside of that car object, right? Or if I have a blender, I can have a blender. The blender, right, has things about it. So it can be different colors. It can be different sizes, right? And it can do different things. So I could tell it to mince or slushy, or I don't have a blender. So, but you know, I know there's different numbers, right? There's different speeds or something. I don't know. I don't need a blender. They're more of a pain to clean than they're worth. I'd rather just mash it up or something. So, but it could do different things, and I can send it different things, right? I could send it fruits or vegetables and things like that. So when I run the functions that it does, I'm like, oh, I want you to run the mincing on these strawberries. So I'll call the function inside of that blender object and tell it to mince these strawberries I send it. And then it will give me back minced strawberries. Okay, so that's what objects are. So all of your objects inside of Animate, all of the symbols that we create, those are all objects. And all those objects, you can attach new functions to them. And they also have built-in functions or methods. I keep saying functions for them, and I call it properties for those values. But they're methods when it's inside of a thing. But it's confusing. Anyway, they all have a bunch of different methods that are already pre-built inside of them. So these are things that can be done, right? So if you have an object, so for instance, like, I might have a graphic, right? I can move that graphic. It has different properties about it, right? So it has position, right? And has different things that it can do. So like I can play an animation inside of that object. I can, have it be a button or run something. There's different things that it can do, all right? So there's also events. So one of the things we're going to be doing is adding events. So you'll see that later on. And we'll call that good. Okay, so hopefully that made some sense. I'm not expecting you guys to like totally understand what I just said or have it make any sense. That's why I did a little bit of coding the last class, and then the idea is that when I talk about it this time, hopefully it makes a little bit more sense. Because if I just went straight into this, you'd be like, I don't have any, there's no touchstone, there's nothing that you would recognize in it. Hopefully at this point you recognize at least a little bit of it. And then what we're going to do today, or right now, because it's not, what you're going to do now is you're going to go down and you are going to, you're going to start making a more complicated game. And the best way to really learn this stuff, there's a lot of theory, don't get me wrong, and you do need to know the theory, but theory doesn't mean anything. The best way to learn is just to do it. And so what I would tell you to do is just follow the tutorials. I explain what we're doing while we're doing them in the tutorial videos. And just when you're doing it, just try to think about logically what I'm saying and try to understand it as best you can. But honestly, you probably won't even really get it until we're basically done. And even then, you're not going to be able to just write the code out. You're going to still probably struggle a little bit. And that's totally fine. Every time I have to go back to a new language, I have to kind of like get myself back in that zone. So, even I can't really just write stuff out straight out. So don't worry if you don't feel like you're entirely getting it. I just want you to know it enough that if you need to create something, you could figure it out. But not expecting you to just, wham, bam, have it done. All right. So hopefully that helps. So after this video, just go ahead and start making the platformer game. When you do it, it's going to kind of end abruptly because it's part of a series. So when you get done with that platformer game, just go ahead and wherever you're at, just go ahead and submit that as far as the assignment is concerned. And then we will carry on in the next week from where you left off. All right. So good luck.